Hey everyone, and welcome to This Explainer. I am absolutely thrilled to have you here today. Look, we all know what ChatGPT is, right? We're probably using it every single day. But today, we're going way beyond the prompt box. We're going to map out the functional anatomy of this system and really understand the precise computational mechanics that make it tick. So let's dive right into this and look at what is literally happening under the hood. Okay, here is our surgical plan for today. First, what is ChatGPT exactly? Second, how ChatGPT actually works. Third, ChatGPT versus traditional chatbots. And finally, real-world uses and applications. All right, starting off with section 1. What is ChatGPT exactly? Let's look at the surface. To put it as simply as possible, ChatGPT is an artificial intelligence, specifically a large language model, or LLM for short. Now, the GPT part stands for Generative Pre-trained Transformer. And while generative and pre-trained basically tell us that it creates new content based on a massive diet of data, the real magic here is actually in that last word, transformer. The transformer is a specific neural network architecture that was introduced back in 2017. Its absolute secret sauce is something called a self-attention mechanism. You see, unlike older AI models that read text strictly from left to right, linearly, self-attention allows the model to weigh the mathematical importance of every single word in a sentence all at once. It maps out the incredibly complex relationships between words, honestly, no matter how far apart they are in a paragraph. And that is exactly what gives the system its uncanny contextual understanding. It isn't just parsing words, it's mathematically mapping the actual geometry of human language. Moving on to section 2, how ChatGPT actually works. Let's get under the hood. So, we arrive at the core question of our explainer today. How does this thing actually work? Think about it. When you type a prompt into that empty text box and hit enter, what is the exact sequence of computational events happening in those few milliseconds before the text starts scrolling across your screen? Let's trace the path together. The system basically operates in 3 really elegant, highly mathematical steps. Step 1 is receiving input. Now, when you type a prompt, the system doesn't actually read English. Nope, instead it breaks your words down into these smaller chunks called tokens and translates those tokens into numerical vectors. Step 2 is processing. Those numerical vectors get sent straight through the transformer network, where they interact with billions or even trillions of parameters. Think of these parameters as mathematical weights that were fine-tuned during the model's huge pre-training phase. The network calculates exactly how your specific string of tokens relates to the vast web of language it's already learned. And finally, step 3 is generating output. So the crucial point you have to remember here is that the model doesn't actually know facts. It doesn't think in full paragraphs. Instead, it operates as this hyper-advanced probability engine. It's just calculating the highest statistical likelihood of what the very next token should be, generating its response one single piece at a time. It's just input, mathematical weighting, and output. Basically a computational heartbeat, constantly predicting the next most logical word.
Section 3, ChatGPT versus traditional chatbots. Time for some comparative anatomy.
And this brilliantly illustrates the massive paradigm shift we've seen in AI recently. You know those traditional rule-based chatbots? They operated on these really rigid decision trees. They lacked what developers call statefulness. That basically means they had absolutely zero memory. Every single time you entered a prompt, the system essentially hit reset. If you asked something even slightly outside their pre-programmed script, boom, you hit a dead end. But ChatGPT fundamentally changes the game through what's known as a context window. Because of its transformer architecture, it can hold thousands of tokens in its active short-term memory simultaneously. And it uses this vast context window to actually inform its next prediction. This is exactly why it can maintain conversational continuity, grasp really deep nuance, and track complex logic across multiple prompts. It isn't just following some static, boring script. It's dynamically updating its statistical calculations based on every single thing that has been said previously in that specific chat session. Which brings us to section 4, real-world uses and applications. Let's see this in the wild. So let's look at how this all builds from basic, everyday utility all the way up to highly complex professional applications. On an everyday level, we all know people use it to instantly draft emails or summarize super long documents, right? And these tasks perfectly leverage the model's ability to seamlessly predict standard linguistic patterns. But as we move into content creation and heavy technical work, well, that's where we see the real power of its underlying pre-training. When a software developer uses this system to write boilerplate code, spot logical errors, or even translate between entire programming languages, the AI is literally applying the exact same predictive mechanics it uses for English. During its training, it maps the
statistical relationships of Python and JavaScript with the exact same structural depth as it did human language. It just adapts its probability engine to the precise syntax of whatever task the user is demanding. It's wild.
But while writing code or drafting emails is obviously super helpful, the single most impactful application we found in our source text is its ability to engage in dynamic, personalized problem solving, basically acting as an interactive tutor. And this goes way, way beyond just adjusting vocabulary. Research actually indicates that one-on-one AI tutoring can drastically improve comprehension speeds. Why? Because the system dynamically adapts to the learner's specific bottlenecks in real time. Think about it. If you ask it to explain quantum physics and its first metaphor just totally flies over your head, you can push back. Its probability engine will instantly recalculate an entirely new pedagogical path based on your feedback. It effectively democratizes access to complex information. It completely shifts the dynamic from a user just blindly searching a database to a student directly collaborating with a highly adaptive, stateful learning partner.
So, what does this all mean for the future? That brings us to our final thought for today. We have traced the computational path of this technology, all the way from token vectors and self-attention mechanisms to vast context windows and incredible real-world applications. But remember, this framework is not static. It is evolving at a breakneck pace. As these models get larger, as context windows expand to hold literally entire books in active memory, and as parameter counts move from billions to potentially trillions, we aren't just looking at a better chatbot anymore. We are looking at the evolution of an entirely new kind of computational reasoning. So how will an even more advanced version of this architecture reshape our world? Something to think about. Thank you so much for joining me on this deep dive today. Keep questioning, keep learning, and I'll see you in the next explainer.